Good morning. This is our warm-up for day 9, and I figured out how I could go ahead and let you see the answers so you could check your answers first, and then we can go over the problems. Now, I'm still going to be going over every problem in the warm-up, so if you only need help with number 7 or number 9, you may want to fast forward the video a little bit. But go ahead and press pause now so that you can check your answers on the sheet with what you see on the screen. And I am going to go ahead and go over to the warm-up. Okay, so for number 1, Paul earns $8 per hour for the first 25 hours he works each week. For every hour he works after 25 hours, he earns $15 an hour. Last week, Paul earned $375. Which equation could be used to find the number of hours, which we're going to use the letter H, during which Paul earned $15 last week? Okay, well, you can see in our answers, 375 is the total that he earned for the week. So that's going to be on the right side of the equation. We just have to figure out what's on the left side. Well, we know that for the first 25 hours, Paul earns $8 an hour, right? But we can also say that as $8 an hour for 25 hours is the same as 25 times 8. So the wage that he makes for the first 25 hours is equal to 25 times 8. Everything after 25 hours, he earns $15 per hour, which this was hour times money, right? So down here, we want to do money times hour. So it would be 15H. So we're looking for an equation that has his first 25 hours, which would be 25 times 8, plus any hours after that, $15 per hour. Equals his total amount that he worked. So that's number 1. Number 2. We are looking for an interval. So line segment A starts here and ends here. Line segment B starts here and ends here. Line segment C starts here and ends here. And line segment D starts here and ends here. So we want something that is linear and increasing. So linear just means that it's a line as opposed to a parabola or a wave. We want a line. Well, they're all lines. So A, B, C, or D, all of them are linear. Increasing means it goes up as it progresses. So up as it goes to the right. Well, A, we can see, goes down as it goes to the right. So it's not A. B goes up as it goes to the right. C doesn't go up or down. D goes down. So it's B. Number 3, a fish swimming 10 feet below the surface of the water leaps to a height of 8 feet above the surface. What is the total height traveled by the fish? If you've got 10 seconds, it helps to draw a picture, even if you're not an artist. So here is my water line, and then I have a cute little fish that is swimming 10 feet below the surface of the water. And he's able to leap to a height of 8 feet above the surface. So the total height traveled by my fish is going to have to be 10 feet to get to the surface of the water, and then 8 feet beyond that. So that would be 10 to get to the surface of the water and 8 above the water, which gives us 18 feet. That's the total height that the fish can travel. Number 4, we got a number line. Point X on the number line right now is between 3 and 4. It's a little bit off, but that's picture error rather than measurement. So we're going to say that X right now is at 3.5, 3.5. Which of these describes the location of the point with the opposite value of point X? Well, if X is 3.5, the opposite value of X would be negative 3.5. So negative 3.5 is going to be up here between negative 3 and negative 4. Opposite value means opposite sign. So I have a positive 3.5 in the beginning. My opposite is a negative 3.5, which is over here. This next one's a transformation. Remember, transformations, we have rotations that are those 90-degree turns. We have reflections, which are like if we had the mirror image and we would flip it. We have translations, which just means we move it up and down or left and right. And those three, reflection, translation, and rotation, don't change the size. Dilations make something bigger or smaller. So we're looking at what transformation would transform the object into the image. Well, we look at the object and the image and we realize they're the same size. So a dilation is not what was used. Then we have to look and see points and lines. And if we look, we've got this lowest point down here is over here. The highest point is here to here, and that middle point is here to here. And if we look at it, we realize that this middle point in the object is closest of all three to that red line. In the image, this middle point is still the one that is closest to the red line. It's a flip. It's a mirror image of the other side. So this would be our mirror right here. And this is our original object, and it got flipped so that it's the mirror image on the other side. So a reflection across a vertical line. Okay. Ground beef costs $3 per pound. Which graph represents the relationship between the total amount of ground beef and the cost? Well, if we know that ground beef costs $3 per pound, then we know this is our y-axis, this is our x-axis. We know that the total cost equals 3 times whatever the weight is. So, if I need to, I can make a quick table. So, if my weight is 2 pounds, then my total cost is going to be 2 times 3, which is 6. If my weight is 4 pounds, my total cost is going to be 4 times 3, which is 12. If my weight is 6 pounds, my total cost is going to be 18. And if my weight is 8 pounds, my total cost is going to be 24. And I realize that my weight in pounds are my X numbers and my total cost are my Y numbers. So one of these charts is going to have the 0.26, the 0.412, the 0.618, and the 0.824 on their line. Well, let's start with chart A. 2 pounds and $6. Yeah, it's looking pretty promising. Then 4 pounds and $12. I think we've got a winner. 6 pounds, 18, and 8 pounds, 24. So, all 4 of these points are on this chart. Now, let's just look at B and see how we can tell that it's wrong. So, my table tells me that at 2 pounds, I should have $6 worth of ground beef. At 4 pounds, I should have 12. So I'm already noticing that the points on my chart are not matching the line on my graph, which means that B is definitely the wrong answer. Number 7. We have an expression, 5 times the quantity of t minus 8. And we talked about with distributive property, if you look inside this parentheses and there's some kind of math happening, here we see t minus 8. You have to treat that t minus 8 like one number. But distributive property tells us that if I want to unpack this parentheses, I can take this number and multiply it by the front number, and then carry the sign, and then multiply it by the second number. So this actually becomes 5 times t minus 5 times 8. And we put these in parentheses so we know that's a number that we need to treat like one number. And that is letter B. Now, if we are going to write it another way, we could write it like this, or we can also write it, remember, 5 times t, bring the sign down, and 5 times 8. So we can also write it as 5 times t, bring the sign over, and 5 times 8 we know is 40. So that's number 7. Okay, Elena's cutting up apples to serve her students. She's planning to serve 3/4 of an apple to each of 9 people. So how many apples does Elena need to cut up? Well, she has 9 people, and she wants to give each one of them 3/4 of an apple. If we're going to multiply fractions, it's easiest to change everything to a fraction. So 9 as a fraction is 9 over 1. Then when we multiply fractions, we go straight across the numerator. So 9 times 3 is 27. And we go straight across the denominator. 1 times 4 is 4. But 27 over 4 isn't one of the answers they give me, so I need to take this from an improper fraction into a mixed number. So remember, I look at how many times 4 goes into 27. 4 goes into 27 6 times. Now 6 times 4 is 24, so I have a remainder of 3. This 6 is my whole number. It's my big number out front. My denominator stays the same as it was from the beginning, and my numerator is the remainder. So 27 over 4 is the same number as 6 3/4. Okay, number line. -6 plus 5. Remember, with a number line, we always start at 0. So we can see right away A starts at 0, B does not. B is starting at 1. So already we can tell just from that B is our wrong answer. But let's go ahead and check A just to make sure. -6 means I start at 0 and I go 6 to the left. Yep. Then plus 5, a positive 5, means that I go 5 to the right, which drops me at -1. And that is the answer to -6 plus 5. So A is the right answer. Last one. Which of these numbers shows the absolute value of -8? It's a little bit hard to see. So which of these numbers shows the absolute value of -8? Absolute values are always positive. Always, always, always. So the absolute value of -8 is 8. It's the same numeral, the same number, but the positive sign. So it will be right here, which is 8. And that is your warm-up. If you have any questions over things, make sure you ask Miss Laura. And I hope you're having a great day. Remember, if you need to get a hold of me, you can send me a text. And as soon as I have cell service to be able to get it, I will get back with you. Hope you're doing well. Miss you guys.